In CAD bus, dominant bit means what should be the logic value?
0.
0. Correct? If you want to send it as data frame, RTR bit should be made as 0. Otherwise, you set it as 1. Recessive bit you set me, it is called a remote frame. Again, send me data. You are asking data for somebody. What data you are asking? That identifier. This message ID, I want this data, please send. Whomever has data, please send. By setting this bit equal to 1, RTR bit, you are saying that I want this data with identification. This identifier, whomever, I want speed data. ABS one engine speed data. What it will do? It will set the RTR bit equal to 1. Correct? If RTR bit is that means it is become a remote frame. The frame sent by the ABS will become a remote frame. It is not a data frame. What it is asking? The identifier. Say for example, data ID equal to 2. That is nothing but the engine speed. Correct? So 2 means immediately engine will send the data in the next frame. That's why it works. Okay. Now we'll see here. There are 3 different nodes. Node 1, node 2, node 3. Correct? The very important, because in exam you are expected to do how it works. Need to understanding very important. Not only exam, I am trying to. So you know that start bit. These are 3 messages. Correct? Message ID, ID 3. Okay, there are 3 ID. There are 3 nodes. All want to send data simultaneously. Please know that when bus is idle, anybody can start transmitting. This is start of the message. All 3 are, the x-axis is nothing but time. At time t equals 0, all are sending start bit. Right? What is start bit? Start bit is a dominant bit. Dominant bit means what? 0.
0.
Correct? All are 0. So that means all 3 are now. See, this is 1 bit. First bit you are sent. Start bit. Everybody says I want to. So everybody keeping quiet. Please note that when you are sending this one, you are also watching what others are sending. Okay. Next comes this is message ID. This is the message ID. Correct? So what is this one? This is sending 0, 1, 0, 1. Correct? This is message ID. What it mean? This is 2. Correct? This is 4. The message ID equal to 6. This is bit 0, bit 1, sorry, bit 2. This is bit 3. It is a 4-bit identifier. We know that 2 power 11, for understanding purpose, we are talking 4 bits. All 4 are transmitted what of bits. This is 0, this is 0, this is 1, this is 1. This is 0, this is 0, this is 1. What is equal in this one? If this is B0, this is nothing but 4, this is nothing but 8. This is ID number 12. B0, B1, B2, B3. By number you know, no? Correct? B0 is nothing. How will you find out the equivalent? This is decimal value. Correct? Bit 0 value multiplied by 2 power 0. Bit 1 value multiplied by 2 power value 1. Bit value 2 multiplied by 2 power 2. Bit 3 multiplied by 2 power 3. Then add all those things. What is bit 0 for this? 0. Correct? So this is nothing but 0 multiplied by 2 power 0. Anything power 0, 1. 1. Correct? 2 power 0, anything to power 0 equal to 1 only. Correct? 2 power 0, 1. 10,000 power 0, 1. Correct? So, but what is the value? Positional value, bit 0. So this is 0. Now, what about the bit to this one? Second bit, in this case, 1. 1 multiplied by 2. This one. So that is nothing but 2. Okay. What about bit 3? 0. 0 multiplied by 2 power 2 is nothing but 4. 0. What is the third one? The bit equal to 1. 1 multiplied by 2 power 3. Correct? 2 into this one, this is 8. So you are getting 8. So 0 plus 2 plus 0 plus 2 power 0, 2 power 1, 2 power 2. This is 2 power, this is wrong. This is nothing but 2 power 8. So 12, sir, this is 0. Okay. 2, 4, 8. Okay. This is 12. Sorry, this is 12. This is 4. So 2 power 2, 2 power this and 4 plus 1 minute, 1 minute. Very small error. I will correct it. So this is ID number. This is 2 plus 8. This is 10. This is 12. This is nothing but 0. This one. This is 8. The ID number. This is 8. This is 12. This one. Now, the first bit, everybody is 0. Everybody is allowed to transmit. When come to next bit, what happened? This bit is high. Correct? This is 0. This is 0. I told you, if recessive bit is there, this ID, this is a recessive bit because this is 1. So what will happen? After transmitting the second bit, this fellow will go out of this one. Why? Because these two have lower number, 0, 0. Automatically, this fellow will drop out from the competition. After second bit, this node 2 will compete because its value is higher than next to ID number. Then in the third bit, correct? In the third bit, what will happen? This is 1, this is 0. Who has to drop now?
No 2.
Why?
Because it has,
Correct.
yeah, it has a recessive value 1.
This is recessive bit, it has to drop. Then now who is left in this one? This fellow gone. Who is now? Node 3. Node 3 can transmit data. Now you become a bus master. Correct? This is how the arbitration is done. For example, I am giving one message. Okay, who will win? Can you tell now if you understood? Okay, start bit, everybody, this is a start bit, SOF. Correct? This is B0, B1, B2, B3. Can you tell who will win? This is node 1, node 2, node 3. Who will win?
Node 3.
Who will win? When you will win the bus? Winning means after that you can transmit the message. Others will just keep quiet.
Lowest number will have, lowest ID will have the winning this thing. So
Yeah, correct. You tell me. I am given the ID number. No, this is message ID number.
Third. 01010, sir.
Why? No, when you will get gain the bus? You are correct. When you will gain the bus, that you need. You have to tell, no. I think there is a small issue. I will come back.
I think saying something, but not good. Some noise are coming here. That is not the problem. Hello.
Hello?
Yes, sir.
Sir,
You're audible.
sir.
You're audible, sir.
Sir, you are audible, sir.
Okay, now which one? I asked question because previously in between it cut. Which node will win? When it will win? When win means, see, first you said SOF, correct? Everybody are allowed. I told you, no, in this case, on the third bit, correct? On the third bit, in this example, on the third bit, the node 3 won the bus, so he can transmit. Please note that even till now, what is transmitting? Not data. What it is transmitting? All three nodes. They are sending only a message identifier. Correct? Based on message identifier, this fellow got on the, this is bit number 1, identifier bit, 2, 3, 4, like that it goes up to 11 bits. Here only 3 bits are shown. On the third bit, during the third bit arbitration, correct? The node 3 won the bus because it all the bits till now, this is 0, 0, 0. This is 0, 0, 1. This is 0, 1, 0. So automatically, this is smaller number. All bits are 0 compared to 0, 0, 1. This is nothing but 2. This is 1. This is 0. Correct? Compared to that, that means this fellow is 1, this one. Now, what I am asking is, I shown another possible combination. When which node will 3, node 1, node 3 already told, which node will gain the bus. This is node 3, node 2, node.
Sir, based on arbitration of bit 0,
Ah.
node 3 will win the bus.
Why? Other two buses has to lose? You are correct. Very good.
Node 1 and node 2 will have low priority.
Yeah, they have recessive bits. In the first bit cell, it is resolved. You need not go to remaining bits. In first bit cell, these two have recessive, but 1, 1. Correct? So only node 3 has dominant bit, 0. That's why these two will automatically drop out. They will listen. So this fellow will start transmitting. What you will transmit next? This message ID 11 bit. After that, all other things. The whole thing you will transmit along with this data. You will transmit everything. So, correct? So here only the arbitration happening. Correct? On the third bit, arbitration happened. So he will transmit remaining for complete message. Correct? Data length, messages, CRC, all this thing will turn. So others will just listen. Now after that, this fellow will become idle. Correct? Again, after some time, everybody will try. All 3, all 4, anybody can try, including this fellow. Correct? This is called idle time. Idle time is fixed by the design. Correct? Minimum idle time has to be there. Correct? So that depends upon what is speed at which, whether you are 100 kilobits, or 125, 500, or 1 megabits, depending upon the speed you want to. So you will listen. Correct? Why? I told you have to wait minimum. Any idea? Minimum period you have to wait for this one idle. So not 1 bit. See, idle period will not be 1 bit, 2 bit, 3 bit duration. Why? Any idea? Guess.
There will be that overlapping, right?
100 microseconds. It can be. Why I tell you? You are transmitting 64-bit data. Correct? Here you are transmitting longest is 64-bit data. This is 15-bit CRC. This is 11 bits, all these things. So you won the bus. Afterwards, you are transmitting all these things. The data itself can have completely 1, 1, 1. 1, 1, 1, 1, 1. 10 bits are 1. What will happen? What will be the data will be going like this? Because this is a recessive bit. No, both the lines will be 2.5 volts. For how long? If the data considered out of 64 bits, correct, 20 bits are 111 by fluke. Correct? Engine speed, all those things is you are combined. No, you are transferring 64. Out of that, there are 10 bits, 20 bits or 111. It is there. 1 means what will happen? Continuous 1 means what will happen? Both the lines will be 2.5 volt. Correct? So this is seen by all other nodes. What they think? They should not think it is idle. Immediately they should not start transmitting data. You got it? Because you are still transmitting data only, 64 bits. Out of the 10 or 12 or 20 bits, even 30 bits can be 1, 1. Correct? There are 8 bytes. Correct? In that, there may be consecutive bits are 1, 1, 1. Then what will happen? Being a recessive bit, the can H, can low will become, both will 2.5 volts only. What is difference this one? That should not be considered as idle. Correct? So that means I transmit one frame for some time. This is 2.5 volt, both the lines. This is the data which is going up and down like this between 3.5 and 1.75 difference voltage. In between also many times it can become low. Correct? Low means 2.5, idle 2.5. Whenever the recessive bits are this one, that should not be considered as a idle, start transmitting. So the idle period should be sufficient long. That depends on what data. Sometimes there's a guidelines. Correct? So one frame, this is frame 1. Frame 2 can be transmitted after giving sufficient idle time. Right? I'm just trying to give information to you. Okay? So now you know
Sir,
how the yes,
that-
please.
So sorry. Is that mean that suppose the transfer rate is you told 1 Mbps? That means the minimum.
1 minute. I'm not able to hear you louder. Little louder if you talk better.
Sorry, sir. What I mean to say is that suppose the data transfer rate is 1 Mbps, right?
Okay. So
That means
you can say that 64 bits are there. No, data is maximum 64 bits. Minimum you have
Yes.
to give 64 bit duration as idle.
Is it? Okay.
That is the longest one, no? In which
It should be more than 1 microsecond at least.
no, each bit is 1 microsecond.
Oh, the 64.
64 microsecond minimum you have to give, no?
Right.
Correct?
Right,
So
sir, thank you.
all bits can be 1, 1, 1. See, you never send, no? All bits, all 64 bits. Engine speed is full. Correct? Torque is full. All 16 bit about no. By fluke it happens. Because data value can vary
Right,
from,
sir.
correct? So 64 microseconds should be the idle time. After that,
At
only
least.
the frame should be transmitted. Otherwise, in between itself, there are chances data collision can happen. Arbitration is always done during identification, identify that duration only. After that, just transmission. Data will be CRC, everything will be transmitted.
Sir,
Yeah.
shall we have a 5 minutes break, sir?
Yeah, we will have. Yes, I will stop here. Yeah,
Thank you, sir. Thank you.
yeah. We can have a break, then we'll continue. Thank you.
Thank you.
Sir, am I audible?
Yeah, yes, please.
Just a practical query.
Hmm.
These CAN buses are used in our vehicle, say for internal switch control, something like that, right? For window winding switches or ORVM operation.
If they use LIN bus, we are going to talk next. But this also can be used.
Okay, so
Bus.
okay. Assuming this CAN bus is used for say front driver side window operation as well as second row passenger side window operation. If both of them are trying to operate the window at the same time, how does that communication work, and how is this related to that?
No. That means are you going to use separate ECU for both, separate individual door?
I'm asking like that only, sir. I don't know. I have not worked in that field, so I'm asking in that sense.
See, generally for each window you will not use one CAN control. No, it is expensive. No, why you want to use?
Correct. It will be in the same bus, and you will try to you do it that way, right? How does it?
Not bus side. Only one ECU.
Okay.
See, I will tell you. These are called body electronics. Correct? In body electronics, there is a one ECU. Okay, on which the door there's only micro switch. Right? There's a motor which is going to move the mirror up and down. Motor controlled by the microcontroller. If it is automatic or manual switch, which will move the mirror up and down. Motor will control mirror up and down. Or you are talking of mirror or door closing and opening?
Window winding opening, sir. Window glass.
That's what I said. That means there's a motor, no? Motorized or manual?
Correct, it is motorized only. Yes.
You have motor, the motor is controlled by ECU, which is going to move the mirror up and down. Right? Now, now how do you know that it is closed, the mirror is gone up? So if you have a window like this, correct? Mirror is coming out, projecting like this, going up, correct? When it
Correct.
reaches the top, there may be a switch here. Inside this, there's a micro switch like this. The switch will be closed. Once it is closed, the ECU is watching the switch. If they, then it will switch off the power to the motor. Power to motor will be off. If micro switch is closed. If micro switch is open means the motor power will go, the mirror will go up. Okay. This is for controlling one window. So like that, I will control same thing for one more this one. Right. Next window, there's a motor which is going to control this. There's a micro switch. Okay, like the 4. Okay. Now, for controlling this, you don't need CAN bus, no? Because this is one ECU.
Understood, sir. So I was having a different query then. Okay, clear.
Okay. Now, this ECU want to talk with, say, for example, ABS ECU. Then you may use CAN bus.
Okay, noted now. Okay.
ABS will be controlling the wheels, all those things. Between these two, you can use the CAN bus.
So, sir, you mean to say that when a controller wants to talk to controller, then CAN bus is useful. Otherwise, for a different part like lights and all those things, simple wire is enough in that.
Wire and switch.
Wire and switch.
Sensor is needed.
Right, sir. So between control to control, if talk is to be happen, then CAN bus is essential.
Bus. It can be CAN bus, it can be LIN bus or RS232 wire bus or bus.
Thank you, sir.
Can there be multiple connections from one sensor to multiple ECUs? For example, for vehicle speed, it is given to 3 different ECUs, let us say. So
Okay.
is it possible or it should pass through the CAN only?
Generally, it will go to one ECU. Main vehicle speed means wheel speed. It will go to automatically ABS only. From ABS, others will receive through CAN bus. Wheel speed is measured by ABS. Individual wheels. There will be wheel speeds and the ECU that will be connected to ABS ECU. You have ABS ECU. Right? It is connected to 4 wheels. Front, left, front, right, back, left, back, right. All these things are this one. From here, this may go to engine ECU. Right? So because the primary the needed is the ABS. We have ABS. Correct? Or it can be connected to ECU. Correct? If you are not using ABS, it may be the wheel speed sensor may be connected to the engine ECU itself. One sensor alone. Correct? One of the sensor may be connected to engine ECU also, without using CAN bus. But generally, this will be done by one main controller which is responsible, and that data will be transmitted to CAN bus or LIN bus, whatever bus it is.
Okay, sir. Clear. Thank you.
Okay. Is visible for you? Screen?
No, sir. The screen is not visible.
Screen not visible, sir.
Now?
Yeah, it's coming.
For after 1 week, there's a problem with my internet here, especially the Google. Chrome has some problem.
Professor, sir,
today-
if you don't get angry, can I ask a question, please?
Why I should get angry?
No. This is regarding exam. That's why I'm asking you.
Okay, no.
I'm sorry to ask this, sir. Basically, the point is, like the syllabus is too vast for the final exam. So, any hint from your side will be very useful for us, if it is possible, sir. It's not a mandatory thing; it's a request in that way.
You are.
I'm taking the risk. I should not be blacklisted.
Don't worry. You have seen that assignment, no?
Yes, sir. Yes, sir. We have seen that.
Oh, that is a hint for you,
Okay, sir. Fine.
for everybody, not only to for everybody.
Of course, of course.
Thank you, sir. Thank you, sir.
Exactly, it will not be same. Similar to that. Right?
Okay. Right, sir.
So no. So 2 marks define something, and one main question 5 marks. Correct? Like that only is going to be.
So basically, sir, the request was that like some questions, if that can be given like options, that will be great. It's just it's a request.
Okay.
The final thing will be.
Don't worry. At least 2 or 3 questions will have option.
Okay, sir.
5 mark question, not this one. For example, see, there will be 6 questions, 60 marks exam. There will be 6 questions, 3 hours. Correct? Each question will have 10 marks. In the 10 mark, the 2 mark was like the small thing and will not have option. Definitely there will be a 5 mark question, 6 marks. That will, in some of the question, 5 marks, 6 marks will have option.
Okay.
For example, write about ABS, one question. Or you talk about this one, something like steering control. 1 or 2 questions, some 6 mark question will have option.
Thank you so much, sir. Thank you so much.
Shall we start?
Sir, we can start, sir. We can start. Sir, we can start, sir.
Okay.
Yes, sir.
So the arbitration, how it is implemented hardware wise, they are using, because this is electronics, don't worry about it. They use what you call AND gate. Correct? That's what this is called, AND gate. Correct? So automatically this taken arbitration is done by electronically. You need not worry, which is inside the CAN controller. This is inside the CAN controller. The arrangement is, I told you, CAN controller is an electronic hardware IC. Inside that, this is implemented. Okay. What is the advantage CAN bus over other things? Important points. It reduces wiring, since it is distributed control, ensure that enhanced system performance. There are only just 2 wires. You can connect up to 256 different ECUs. Correct? Just parallelly you connect. Tap it. We call tapping. One long wire is going, tap. Connect to controller. Again, tap. Connect to a controller. Like this you can. So simple. Then end there's a 2 termination resistors. Very simple. Correct? And the one thing. Then many CAN chip manufacturers provide data link layer and the physical layer interface in chip itself. The software developer needs to do only develop an application code. Please know that CAN bus is not just connecting IC. You need to write some program also. The CAN controller should be programmed. Correct? So if you buy a CAN chip, correct? I told you this CAN chip. It's like a small microprocessor. Correct? The CAN controller IC is like a small microprocessor. This need to be programmed. They give libraries, all this thing. This fellow itself, if you buy, this is Intel. Intel CPU, this is Intel CAN controller IC. Because many people are making CAN controller easily available, but you can buy it easily available because my student is using. You saw, no, CAN controller costs 500 rupees only or 400 rupees, this CAN controller. And the library, everything you will give. Because we bought an Arduino board, my student, correct? Plus this CAN controller board, again Arduino CAN controller. both are two separate small boards. They're connected. This fellow giving library, all those things you can program easy. Okay, but that's why all those things are already given by the manufacturer. CAN control IC manufacturer itself gives very small amount of program you have to write. That's what we are talking. Okay, so the software development, so some amount of work you have to do, right? Then it provides ability to work different electrical element, ensures noise-free transmission. Why? It is twisted pair wire, which automatic EMI noise is reduced, and also differential voltage bus, correct? So both things ensures EMI error-free transmission. Traffic congestion eliminated because transmitted based on the priority, correct? If two devices are trying to simultaneously transmit, the data is not because arbitration, already just now we talked, correct? The CPU which has low data ID, whose ID is lower than other, get the priority, automatically others drops. So data never collides, so data is definitely ensured, correct? So that is advantage, which is not possible in other this one. Then it provides error-free transit. Each node can check error, and also using what you call CRC, cyclic redundancy code. We'll see that. Okay. CAN bus implement 5 levels of error detection, correct? In case of RS-232, only parity bit is available, correct? 1 bit error can be detected. It uses, at message level, it uses cyclic CRC code and frame checks and acknowledgement checks, correct? It uses CRC, frame check, and acknowledgement. These are 3 type of error message available, correct? Which can be included as a part of the CAN frame itself. Please remember this. This is what we are talking, correct? You have CRC, correct? Then acknowledgement bit, correct? And RTR bit, correct? RTR bit. All those things are used for checking error, okay? As a part of the frame itself. Then bit level checking is there, correct? Monitoring and stuffing. We don't worry about that. This is little higher, nothing to worry, but just know that the possible 5 level. Then the primary, this one is it use CRC, cyclic redundancy error code, using 15-bit CRC computed by the transmitter from the message contents. Okay, it uses a polynomial of this. First degree polynomial, second degree polynomial like this. This is 15-degree polynomial use. It uses this polynomial, correct? So what it means, we know that 15, correct? So if we take a 15-bit binary data, okay, okay, the particular bits alone is set as 1, correct? We can say that this bit is set as 1, this is 14, correct? This 14th bit, this is 13th bit, this is 12th, 11. This bit, this is 10th bit, this is set as 1, correct? 9 is 0, that means these bits are 0. This 8 equal to 1, 7 equal to 1, then 0, 0, and 4 equal to 1, correct? 3 equal to 1, 0, 0. Okay. These bits are multiplied with polynomial. Now, the CRC code, who is generating CRC, like parity code, this is generated by the transmitter. Transmitter generates this code and adds with the data other bits and generate the frame and is sent. Receiver side, this receiver again recalculates the CRC, correct? So CRC values, 15-bit CRC is computed by the transmitter and added and sent along with the data, correct? There it is a parity bit. The receiver recalculates from the data, 64-bit data, the receiver recalculates the CRC and it cross-checks whether transmitted is same as received. If there's an error, we know that there's an error in the bit. That's how it calculates. Compares with again transmitted value. If any discrepancy between there, error flag is set, correct? Then the receiver says you transmit data again. Okay. finally, the each receiving node writes a dominant bit acknowledged bit of the message from that ready to transmitting node. If message is not acknowledged, that means error is a where. So we know that in this case, yeah, you see here acknowledgement, correct? So if while transmitting, this is set as a recessive bit 1. Receiver cross check the CRC, correct? If after cross checking, if there's an error, this bit will be made as 0. That means the transmitter knows that receive data, there's an error. So it will again retransmit data. Okay, I'm just giving a fair idea because you need to understand, but we don't have time to see everything. Yeah, 1 minute. Yeah. So this is how it happens. So as I told you, for you to understand how the CRC, the node A, which is transmitting, the data is there, some data is there. It calculated the CRC. The CRC value was checksum value 1, 2, 3, 4 H. H means hexadecimal. Correct? This is transmitted along with the data through this, because this is CRC. This is the data. This is the start bit. Other bits are here. This is transmitted. It is received. The receiver again calculates the checksum, received checksum. This is a calculated checksum. How it calculates? From the data received. This data, using that, this is calculated. Both are compared. If there's a mismatch, automatically it will trigger the RTR bit, retransmit bit. Okay, and then the data will be again retransmitted by the controller. Any doubts? At least something you need to understand. That's why I'm just asking. So as I told, CRC check. Another thing, if the receiver does not do the acknowledgement, correct? We know that this acknowledgement bit is there. If this acknowledgement bit remains 1, even after a long time, automatically the transmitter knows that the data is not received by the receiver. There is some problem. Correct? Again, the transmitter may retransmit. This is another way of acknowledging error. We told there are 5 different methods in CAN bus. In case of RS232, only 1 parity bit only. Correct? That is 1 bit error only. Here, there are 5 different ways to identify whether the received data has an error. CRC checking, acknowledgement. If acknowledgement bit is not received, correct? It is set by 1 by the transmitter. The receiver should set it 0 after receiving data. Correct? That is why the acknowledgement bit is in the here. Right? You can see that the acknowledgement bit is after the data CRC calculation, acknowledgement bit. This is sent as 1. Correct? After the receiver should make it as 0. If it is not received, then transmit know the data is not received. The end of frame. Next bit is the end of frame. Correct? Then bus idle. So this transmitter will wait. If the bit becomes 0, it knows that for wait for some time, nothing happened. That means there's a send data is faulty or not received. So the whole frame may be transmitted by the transmitter. That you decide whether you want to retransmit all this thing as a design of the controller. Okay, see, this is how it looks. Please see that. That's what I told you. Your frame, right? So this is the start of the frame. You can see the start of frame is 0. This is message ID, correct? 11-bit ID, correct? So this is bit 0, ID 0, ID 1. This is the 11th bit, correct? So 0, 0, 0. What is this ID? This is equal to, I will tell you, this is 0, 4. This ID is 17. ID number 17, because these two all other bits are 0. This message ID equal to 17. Right? Binary representation like this. Right? But actually ID number 17. Then he is transmitting only 1 byte. You can see that he is transmitting only 1 byte of data. This is 1 byte of data. Correct? Data length is set to 1. Correct? You see that it is set to 1. If you put 0010, that means he is going to send 2 bytes of data. If you set 0100, 4 bytes. 0101 means 5 bytes. So 111 means all the 8 bytes. These 4 bits represent data length. In this case, is set equal to 1 only. That means 1 byte. That's why he is transferring only 1 byte of data. Correct? Otherwise, after that, this is CRC field. Correct? For this data, he checked the CRC, computer CRC, that value is set. Correct? Then CRC delimiter, then acknowledgement slot bit. Correct? This is acknowledgement delimiter, then end of the frame. Okay? The other extra bits. So that will be transmitted as scan. You can see here. This is 2.5 volt. Both are 2.5 volt. During this bit, it is dominant. How many bits? 1, 2, 3, 4, 5, 6, 7. 7 bit duration. Because all the bits are 0, this will become 3.5 volts. This will become 1.5 volts. The difference equal to 2 volts. Right? This is called dominant bit, zeros. This is only 1 bit is recessive bit. So both become 2.5. Again, 1 dominant bit. Again, 2.5 recessive bigger because this is recessive 1 means. Again, down you can see the entire period is 0. Correct? So that means this is dominant bit. Again, 1 bit is recessive. Again, this is dominant. So 1, 2, 3, 4, 5, 6, 7. 7 bit duration dominant. This is 3.5 volt. This is 1.5 volt. Difference is 2. Same thing. Like this. Correct? The end of wave. After that, this may become like this. This is idle period. Correct? Maybe some 64 bits something. Long gap. Then again next frame starts. You got it? Okay. All this thing we are not going to overload. All this thing you can see later. Correct? Bus loading bit I am not going to talk about today. Okay. Okay, important points you can note down. CAN bus is a serial network bus used for embedded applications, generally used for automobiles and industrial automation, wherever you want. Nothing stops. You can do anywhere you want to transmit data. This one. It is a two-way communication bus using a twisted pair, which is called a CAN-H and CAN-LO. Twisted pair reduces EMI noise, and also it uses differential signal. Differential signal. So EMI is reduced. Correct? Even wherever noise, too much noise there, you can use CAN bus. Still, the bus will work properly. It operates speed up to 1 megabits per second. Newer, latest to CAN bus, you can go to CAN FD. Correct? CAN 2.0A, 2.B uses 1 MB maximum. Right? You can CAN, if you use latest, you can go 8 MB bits. And it generally allows data to transmit as 60. The CAN FD allows up to 64 bytes. 64 into 8 bits. You can see. But in case of CAN H and this is only 64 bits or 8 bytes. CAN 2.0 only 64 bits or 8 bytes. If you go for CAN FD, latest version, you can go up to 64 bytes or 61 8 bits of data you can transmit. Does not support node IDs, but only has a message ID. Node doesn't have any ID at all in CAN bus. Correct? Only message as ID. Support message priority. That's what I told. Lowest the message ID, it has highest priority. Correct? Message ID 0 has the highest priority compared to any other thing. ID is 2047 in case of 2.0 and in case of 2.0 this one 29 bit, that is bigger. Support two messages, 11 bit standard or 21 bit is extended, that is CAN 2.0. In CAN 2.0 you can have 2 power 29 different messages. Avoid message correction by implementing carrier multiple direction arbitration mechanism. It is use. Okay, we saw this. So now let us see what is the CRC. Okay, how this checksum is generated. Okay, For example, I have a data, 4 bytes of data, correct? First byte, second byte, third byte, each byte has 8-bit data, totally 32 bit, correct? So this is bit 0, bit 1, this is the bit 31, the last one. Okay. Now, in checksum error deduction scheme, data is divided into k segments of m bits, correct? So here 32 bits are there. I have divided into k, correct, segments, right? 4 segments. That means automatically the divided this is 8 bits. Each segment consists of 8 bits. You can have different, but generally here we have used a byte as a unit. So 32 bit divided by 4 segments, automatically each is this one. So m equal this one. Now before transmitting data, segments are added using one's complement arithmetic to get this sum. The sum is complemented to get the checksum. Okay. Now the transmitter, you see the first 2 bytes, no? We have, this is the first byte, this is second byte, or the segment. These 2 segments are added, correct? You can see that segments are added using one's complement. Okay, one's complement will be used for adding these 2 data, and you get the results. Okay, now this is called carry. When you add this, you get the carry, correct? That carry is brought here. Now this carry will be added with this. Again, you are getting, this is checksum for these 2 bytes of data. For these 2 bytes of first to add, how will you get one's complement? Add these 2 numbers, right? You get a carry. The carry will be added again with the addition. This is added value. They call binary addition. You know binary addition?
Forgot, sir.
Okay, very simple. So the binary addition, this, so 0 plus 1, 1. 1 plus 0, 1. 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 0. Sorry, 1. Correct? This also same. But 1 plus 1, what? 1 plus 1 means 0 is the sum, 1 is the carry. Correct? In binary, you can have only 1 value, no? So this is the sum. 1 plus 1 means sum equal to 0, carry equal to 1. So you already added. Now the carry will be brought here. The carry is brought here. Now again you add. Correct? This is the sum of these 2 bytes. These 2 are added. Binary summation. You got 1 carry. Correct? That carry is brought here. Now again add this. So 1 plus 1, 0 sum, 1 carry is there. Correct? This 1 plus 1 means sum is 0, 1 carry is there. That carry is again added with this. Again 1 plus 1, 0. What is available? Again 1 carry is there. Correct? This carry brought here. 0 plus 1, 1. Correct? Here everywhere 0 is there. So again 1, 1, but 0 plus this one like you do. Correct? Finally, you get this value. So this is the one's complement addition. That's what we are talking. Carry if you add, finally this is 1 complement's value. One's complement. Okay. Then with this 1 complement, you have to add this, just bringing this data here. Again do the 0, 0, 0, 0, 0, 0. Correct? 1, 1, 0 sum. The carry is there. The carry goes here. 1 plus 1, 0. Again carry is there. 1 plus 1, 0. Carry is there. Again 1 plus 1, 1 plus 1. Again 1 is here. There's a carry. The carry comes here. 1 plus 1, 0. 1 carry is there. You add here, it becomes 1. Correct? So here there's no carry. Correct? So if the carry is not there, automatically you can add the 4th byte. When you add carry, you are getting this one. If the carry is available, that should be added with this one. Finally, you are getting this. Correct? This is the sum of all the 4 bytes. Okay. Now you have to do one's complement. One's complement. This is this check sum. Now to get the checksum, you have to do complement, one's complement. One's complement, what you will do? 1 will become 0, 0 will become 1. Correct? So this is 1, this becomes 0. This is 0, this become 1. This is 1, this is 0. Like that, if you do, finally you are getting checksum. Correct? For this 4 original data is this. For that, checksum is this. Who is created, does this, all this business? The transmitting device. What it will do? It will take this checksum and add where? Correct? Here. It will add the checksum here. And the data is here. Correct? So here we have shown only 4 byte. That means 4 byte data, byte 1 like this. This is byte 4. Then the checksum will be added. And the start bit, message ID, all those things. This whole thing is created and will be transmitted. Okay? Okay, what the receiver has to do now? Okay, this is the checksum generated by the transmitter. And you are sent this data. This data again, the same business receiver also doing. You can see here. Same thing receiver also doing. Correct? Then he calculates this one. Checksum. This is checksum after complementation. Correct? This is the checksum. Here, what is checksum? 1 1 0 1 1 0 1. What is here? Everything is 0. That means received data is wrong. So the cyclic redundancy code is error detecting code, correct? Used for communication. The packet data, block of data, which is nothing but the data, original data, what you wanted to data, will be used for creating checksum, correct? The checksum was generated by doing binary addition and finding the ones complement, correct? So this is sum of the 4 bytes. Then you do ones complement. This is ones complement, which is called sum. This will be transmitted along with data. The checksum plus this will be added along start bit, all those things. Receiver will again find the checksum, correct? And it will compare, receiver will compare the received checksum. This is received checksum with the calculated checksum. If there's error, we know that there's error. What it will do? If the error retransmit bit will be made as 0. Automatically transmit over the received data, so it will send it. Okay. So on receiving calculus repeated by this one, the checksum don't match, the corrective action unit is asking for retransmission or any other thing. CRC is called n-bit CRC when check bit is n-bit long. Here they are using 15-bit CRC. In CAN bus, they are using 15-bit CRC code. Correct? 12-bit CRC also used for GSM. Cell phones, no GSM message. They are using 12-bit, but in case of CAN bus, they have 16-bit CAN bus. Okay, there was CRC 15. Okay, so this is how it does for you to understand data, correct? From that, does all those things, find the CRC, data plus CRC is sent to the receiver. Receiver again calculates the CRC and compares with this. If it is both are same, accept. If the both are different, reject. Okay, this is CRC computation comparison, all those things. Many methods are there calculating. One method I showed, this is another method. Okay, so I think I'll stop here. Okay, any questions? No question means I'll stop the class today. Tomorrow we'll start about Linbus. Then we'll talk wireless bus, wireless communication.
Okay, sir.
Okay, sir. Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you very much.
Okay. Give this attendance as a chat message. That is very important for attendance. Don't forget to give the chat message.
Sir, I think nobody has missed any class of yours.
Fine, but anyhow, I need officially need a record.
Right, sir. Right.
Because in attendance, I have to send it to academic. That will be printed in your attendance, in your grade sheet. Attendance grade, whether it is a G, correct? You have, there are 3 things. P means poor. you cannot write the exam. If you have less than 75% attendance in last 42 hours when I complete, you cannot write the NSEM exam. You are P. You will get W grade. You are fail automatically. You have to attend the course next time. Correct? If you have greater than 75%, you will get from greater than 75, less than 85%. Then it will get M grade, marginal grade. If you have attendance greater than 85, less than 95, you will get G, good grade. This will be there. In your mark sheet, you will get S, A, B like this, E grade, U is failed. And the W grade means you have to repeat the course. For each course, you will get this. This is how IIT works. S grade is highest grade. E means pass, just to pass. You got maybe around very 30 marks, 20 marks, total out of 100 after all the exam assignments. U means failed. W means you did not have attendance to write the exam less than 75%. In fact, as per IIT rule, I have to calculate before the exam, in some exam, if you have 75% to attend less than 75, you are not allowed to write the exam. You have to attend this course once again next year, along with your next batch student. Okay. If your attendance is above greater than 75, less than 85, you will get M grade, marginal grade. You will say that, for example, you are getting A grade, correct? For the exam, this is your grade, correct? Then attendance grade, attendance AG will be, for example, your attendance percentage 76, you will get M. So it will be indicated in your grade card. So ME 5306, introduction autonomous vehicle, the grade equal to A, attendance grade equal to M. It will be printed permanently. So next course you are doing ME some XX, you are doing another course. You got, for example, S grade, correct? You got there, you attended full classes above 85%, less than, you will get G. If you get above 95%, greater than 95, correct? You will get VG, very good grade. This will be automatically. That is why we need compulsory. I have to calculate and send. Okay, that's why I'm asking. You have to attend all the classes. If you miss these classes, if attendance becomes less than 75%, some teacher won't allow. Please remember, even 74%. Sometimes they will ask you to switch on your camera, see you whether you are in the class. In fact, I used to do every time before taking attendance. Say yes, sir. I want to physically see, because many times people log in and they should just go away, camera off. Because a regular student used to do, correct? Online classes, my class was 121 course was 120 students, 88 students. I'll be taking under this one. I ask the students or name, call the name, he won't be there. Can you switch on your camera? No response. Then I say that I'll log out. 1 hour class is over. I see some 20 students will not be log out. That means they are not there. Just logged in, simply vanished. Correct? Camera off. Then I put all those students, I put attendance equal absent only that day. I told me, I have done. I told 10 students did not allow to write the exam. Because they were doing regularly like this. I said, they have to repeat the course once again. They did the course once again. I put less than 75%. So W, poor attendance grade. Automatically, computer in IIT will calculate W grade. W means you have to attend the class again one more semester. You cannot write, nothing you can do. You have to attend all the 42 hours, register next year, again you have to do. That should not happen. I'm just telling you what can happen. Correct? Next semester, some other teacher may be teaching. Correct? So they may ask, every day they take class. Correct? If you are not there, they say this student had 70%. Correct? I won't allow. You cannot go to dean, wherever you go, he won't allow. Teacher is the final year, as per attendance is concerned. Unless you have medical certificate produced, suppose you have 70%, correct? So you are not attended class, some 10 class or 5 class due to some medical emergency. That also, you have to get hospitalized, correct? Something emergency, you have to produce certificate. Then only they accept. That also dean has to accept. In fact, for IIT student, they have to get certificate from IIT hospital, not from outside. Because student go and give some 500 rupees, the doctor gives 20 days he was in hospital admitted. Correct? IIT doesn't accept. They want from IIT hospital that you was admitted in the hospital for 15 days. Outside, they don't accept. No, so sometimes students do it. That's why I'm telling. Right? Sometimes I was like that only. I'm teaching for 20 years. 10 students I did not allow. They could not write the exam. I said no. They went to dean. All this said they, because the attendance is only 65%. They are not attending class regularly, online classes. Over. Regular class also happened 10 years before. Right? So I'm just telling you, teachers sometimes may be very strict. That's why I'm asking you to give attendance. Attendance is important. If attendance is not there, officially on record is not there, so I will put to P grade. So you cannot write this course. You have to repeat once again with your juniors. That should not happen. I'm just telling you other because next semester 2 more courses come. I correct other 2 courses we are going to finalize who will be teaching. They may be taking attendance every day. They want to see you. They check 2 or 3. Please note that in between they ask you to switch on your camera. You cannot say my camera is not working. All this thing. That one teacher said nothing. Even a camera, you do. I can't do it. Right? Students who used to do this, just switch on the camera, log in for 2 hours. Also, it will be online. That means he is sleeping something else or somewhere else. He thinks just logging in, switching off the camera, he can get attendance. Many students failed. They could not write exam. Okay, fine. So don't worry about that. Just giving, correct? As a say, I'm not talking as a teacher. I'm talking as a coordinator. Because you are my student. By next semester, suppose you think that I buy just logging in. If you say that my camera is not working, you'll say buy a new camera. Otherwise, don't attend the class. Teacher can say that. No, student used to do that. Sir, I don't have camera. My system is not working. I told her, camera was 500 rupees. Correct? USB camera 500. You buy he said my laptop camera failed. Okay, attach an external camera, 300 rupees. Correct? Student, no. See, I said, I am here for last 25 years, I'm teaching. No, I'm seeing all possible combinations. Correct? Sometimes, I myself am very strict. Attendance not there means literally 3 times I stop. Correct? They want to dean, all this thing, I said nothing doing. Correct? This rule is set by not by me. 75% all this thing is by the this one board of this one Senate and by dean. Dean sends mail every semester. You have to take attendance. If less than, don't allow exam. He only sends mail to all the teachers, all 650 teachers. So when one student went to dean asked me what happened. Sir, you send your rule, I am following the rule. Dean said, yes, Manivannan, very good, fantastic. Beyond that, he cannot talk. If student thought he's going to dean, he will get permission to write the exam. I said, sir, you only give permission, sir, to maintain attendance. I took attendance, it's not there. Then dean could not talk anything. I did not allow the 10 students to write the exam. Because they are 65%, 50% switching on the camera and not visible, all those things. Right? I'm just telling you, don't worry about this. This is how the system works. You should know, aware of it. Correct? Later, sir, he did not give that teacher. Teacher will follow institute rule. We cannot blame him, no. Because I will tell you, in fact, one teacher, sir, company is paying money, paying fees, everything. They are giving a chance to do a higher studies. Correct? The students are not attending, just switching on this one, logging in. Correct? I'm just telling you. I am not telling you did it. Right? I don't know anybody. I'm just telling you, they are also important. Attendance also important. Because later it should not be in trouble. That teacher did not allow, I had a poor attendance, so he did not allow. So because without passing course, you won't get degree. Correct? I'm just trying to help you. See you tomorrow. Sorry for taking on 5 minutes. This is just as a coordinator, you are my student. I'm not only for this, I'm responsible. See that I guide you properly. You should know all the rules and regulations. Later, sorry, if you are told you to do carefully, you should not feel regret. Correct? Correct? Later, you don't feel. Correct? Some teachers said because you didn't have attendance, I did not allow. Then crying will not help. That's what I'm just saying.
Okay, sir. Sure, sir. Thank you for that, sir.
Thank you, sir. Thank you.
Thank you.
Thank you, sir.